Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 5 in the HTTP host header attacks module titled SSRF via flawed request parsing. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portsfigure.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy. Select all content and then all labs, and then do a search on host header attacks and go to lab number 5 titled SSRF via flawed request parsing. Alright, let's get started. This lab is vulnerable to routing-based SSRF due to its flawed parsing of the request's intended host. You can exploit this to access an insecure intranet admin panel located at an internal IP address. To solve the lab, access the internal admin panel located in this range over here, then delete the user Carlos. We also have a note that says to prevent the Academy platform from being used to attack third parties, our firewall blocks interactions between the labs and arbitrary external systems. To solve the lab, you must use Burp Collaborator's default public server. Alright, so the vulnerable parameter over here is the host header, and the goal is to exploit the host header injection in order to perform an SSRF attack so that you could gain access to an internal admin panel and delete the user Carlos. And for creds over here, we're actually not given any creds, so we're going to remove that. That's from a previous lab. And so we're going to operate without any credentials. In the previous lab, we exploited an SSRF vulnerability as well, so this will be a variation of the exploit that we performed last time. If you haven't watched that lab, I definitely recommend that you watch it before you watch this video, because in that video, since it was the first time that we exploit an SSRF vulnerability using a host header injection, we explained that in detail. Whereas in this lab over here, we're going to assume that we already know that piece of information. All right, let's access the lab. Now, notice over here, I am using the built-in browser in Burp, and so all my requests are already being passed in my Burp proxy. I am using the professional version because I do want to use Collaborator to confirm that the application is vulnerable. However, if you only have the free version or the community edition, you could watch the steps to use Collaborator to confirm the vulnerability, but to actually exploit the vulnerability, you don't need the professional version. We'll use Intruder for that, and so you can finish this lab without the professional version of Burp. All right, the first thing we're going to do is click on the home page, and then we're going to send that request to repeater just like we did with the previous lab. And we want to see if the host header is vulnerable to host header injection so that we could perform an SSRF attack. So similar to the previous lab, we're going to go to Collaborator, click on Get Started, and then copy to Clipboard. And in Repeater over here, if we hit Send, you could see that it displays the page. However, if we change it to our attacker-controlled server, which is the Collaborator public server over here, and hit Send, we get a client error saying it's forbidden. So in the previous lab, we were able to exploit the vulnerability because it accepted an arbitrary host. In this lab, it looks like it doesn't accept an arbitrary host, so we need to see if maybe there are inconsistencies or ambiguities with how this host header is handled to the point that it might potentially lead to a vulnerability. So let's see if it just parses a portion of the host header. Let's say .ranakhalil.com. Hit send. Still doesn't work. Next, let's try a subdomain, ranakhalil.com. And actually, we're doing this incorrectly. What we need is we need the original host for this to work. So I'll just confirm this works. Okay, perfect. Now we're seeing if potentially it's only parsing a portion of the header instead of all the header. And so let's add our domain over here and see if it still works. And it doesn't. So this test case is out of the picture. Now let's see if maybe if a subdomain is vulnerable, then we could use that subdomain in order to attack this domain over here. Of course, this is not the ideal test case, even if it works, because we would need to find a valid subdomain in order to perform this exploit. So hit send. Okay, it still does not work. So it looks like it is properly parsing this host header and checking to see that not an arbitrary value is being entered. Next, you could inject ambiguous requests in hopes that it confuses the backend or it's handled by the backend in such a way that it makes it potentially vulnerable. So one of the test cases that you could try is you could try to inject duplicate host headers. So let's copy that and add another host header. For now, I'm going to keep them the same and see if it works. And it looks like it is working. Now let's add our collaborator server as one of the host headers and see how the application responds. So let's put it at the bottom one, hit send, and we get an error. So that's not working. Let's go back and put it on the top one and see if that works. Hit send, and we still get an error. So let's just remove the duplicate host header and keep the valid one. This test case also didn't work. Next test case that you could try is you could supply an absolute URL. So this request line over here usually specifies a relative path on the requested domain. However, sometimes servers are also configured to understand requests for absolute URLs. So that would be the full URL. Let's try that. Let's copy the full URL, which you could just get from over here. And instead of just slash, we put in the full URL and see if it accepts it. It does, so that's interesting. If you right click and say show in browser, so show response in browser, you could see it's the exact same page that we're requesting over here. Hit enter, and here we go. It's the exact same page over here. So this tells me that you can supply the absolute URL in this request line over here. Now, supplying both the absolute URL in this request line and in the host header can lead to discrepancies between different systems, and these discrepancies, if they're handled incorrectly, they can lead to vulnerabilities. So the application may be checking this one, and if this one is valid, it forgets about checking this one. So we're going to go back to collaborator, copy to clipboard, go back to repeater, and now change the host header, assuming that we have the correct one over here in this request line. Hit send, and we do not get a timeout. Interesting. So we get the page of our collaborator server. This tells me that this is vulnerable to host header injection and to SSRF. So if we go to collaborator and we poll now, you could see that we got a ping back from the application server. So we've identified a case in the application that could potentially lead to a vulnerability. However, what we need to keep doing is ensure that the absolute header is in this request line so that the application does not reject our request. Now, for the lab, in order to complete it, we need to be able to access the internal admin panel, which is located somewhere in this range. And so we need to perform an IP scan. Let's send that to intruder. This is the part that you could perform with the community edition. Let's go over here, and instead of our burp collaborator, we put in the IP address and then click add on the last number, go to payloads, click on numbers and go from 1 to 254. That's the range we're looking for, and the step count is 1, which means it'll start off with 192.168.0.1 and then go to .2, .3, .4, and so on. The next step that you need to perform is to uncheck this checkbox over here that says update host header to match the target, because our host header definitely doesn't match the target. Let's click on start attack, click on ignore. And if you're using the community edition, this is going to be much slower than the professional version because the community edition is heavily throttled. So The scan is done. What I'm looking for is a different status code, so I'm going to order on that. And right away, I see that 302, so this IP address gives me a different status code and a different length for the request. And you could see it leads me to a /admin panel. So I can confirm on this internal IP address, I have an HTTP server, and that HTTP server has an admin directory. So let's close this off and go back to repeater. And in repeater, we're going to go with the IP address that we identified. Now in the host header over here, we can't add /admin. So if we click send right over here, it says it's directing me to /admin. We can't add /admin over here. So what we're going to do is we're going to add it in this request line. So the hope over here is that the application is parsing this to check if we have a valid host or a valid URL, valid domain name. It confirms that, and then when it's processing the request, it actually takes in the host header and then uses the relative path that is included over here. So in order for this to be vulnerable, it would need to check 192.168.0.243/admin. Let's see if that works. Hit send, and we get a 200 OK. So this is a really good sign. It tells me that it is going to work. Let's look at that in the browser. So show response in the browser, copy, and paste it in here and see what we get. So we're getting a page that takes in a username and allows you to delete a user. Let's try and delete Carlos. We do it from over here. It's not going to work because the host header is incorrect. So if you go to proxy right over here, and send this one to repeater, you could see the host header is back to the correct host header of the application, which the application is not going to accept. So we're not trying to see the admin panel over here for this host header. We're doing it for the IP address that we identified. That's where the admin panel exists. So we're going to copy this, paste it in here. And then we need to add the absolute URL over here, because if we do this, it'll give me an error. So you could see over here, it gave me an error because I'm trying to access an internal resource directly from the application. And so let's copy the absolute URL, paste it in here, hit send, and we also get an error, which is weird. Let's see what we're doing wrong. So 192.168.243, this looks good. Let's go back. Hit send again. And let's go back and work from a valid request. Okay, so this over here, I'm just going back to the valid request. Hit send, and we get a not found. Okay, good. Next, we need to copy our correct IP address. Add it in host, hit send, and we get a forbidden error. And then we need to copy the absolute URL, put it in here, and hit send, and we get a 302. Okay, so the attack worked. I likely had an extra space the last time around, and so I just had to repeat my steps again. So what's happening over here, which is a really, really weird test case, and I wouldn't have thought of exploiting this or performing this test case in a real world scenario before learning about this lab. But what's happening over here is that there's a discrepancy between checking the absolute URL and checking the host header. It looks like it confirms the correctness of the domain using this request line over here. However, when it's trying to access the page, it uses the host header to access this specific URL, and then it uses this relative path to access the directories or these pages in this URL over here. And so this is allowing us to delete the Carlos user. Since we got a 302, I know my exploit worked, but if we go back over here, you could see it says, congratulations, you solved the lab. All right, so we were able to successfully complete the exercise. In the next lab, we'll look at another attack vector that you can perform when you have a host header injection vulnerability.